Today we're going to be learning about scripting, and I'm very relieved because I thought we'd come to the end of the docs, but we're lucky and there's a few more things that the docs can tell us about scripting. We're going to be exploring workflows and how to convert workflows to scripts today. And for that, the first thing I'm going to do is to analyze a whole image, applying everything we've learned until now at a very, very sped up pace, just so that we have all those steps locked. And then we'll see how to turn that into a script. So here we go. Hi, voiceover Laura here, going through the steps. So the first thing, we're doing the stem separation in this square annotation here. We check that we've done a good enough separation. It seems like we're happy with that. Next thing we're going to do is we're going to try and segment the tissue. Here I'm trying to do it with a pixel threshold. Having some level of success, trying different thresholds. In here I appear to, although at a very high resolution, have achieved a very nice threshold. I decided it's too much, so I decreased the resolution. I save this classifier. And then I soon realized that this is just, it's too much detail. So I decide to do a manual annotation instead. So I do, with the one tool, a manual annotation of the main tissue area. And in that tissue area, I'm going to do the positive cell detection. I choose the optical density sum for that. And if you see here, I've chosen a threshold that is only detecting the positive cells, not every cell. That's why I look confused here. Yeah, I don't like how this is going because I'm just getting the brown cells. So I try it again with a different threshold, and now it works beautifully. So I apply that to the whole image. With the same parameters that worked for the tiny square annotation. Wait a bit because it's quite a big area. And there we go. It worked. Great. And now I do the measurement maps to see the areas where the positive cells are more dense. And with that, I use it to create annotations for a object classification to differentiate between stromal and tumor areas. Again, I'm not a pathologist, so I might be doing this wrong in a biological sense, but the pipeline is how it's supposed to be done. Didn't quite like what it was doing, so I'm trying it again in a smaller area. It's possibly just that I wasn't seeing the green areas well enough because of a low contrast. So I just try again. It's fine to try again things when you're not happy with them. That's what this is for. I use the measurement maps again and try a third time to train a good object classification here. And now I'm happier with the result. It's probably the same result, it's just the green is more visible. And I save this classifier. Next thing, I check that the intensity threshold is good for the positive cells. And I create density maps to check for hotspots in these areas with a lot of positive cells. I save that, create a few nice hotspots, both with normal hotspots and with threshold. I save it as an image just to check, because I've never done that. It looks nice. And yeah, here I am checking the annotations and feeling confident with the pipeline that I've done. So now we have a workflow with all the actions that we've done with this image. So we have how we've set the image type, the stains, we've deleted some objects, we've done positive cell detection, everything we've done is here. So this is our whole history with this image. And now you can see that some of this is repeated. There are some missing things, like for instance, the manual annotations are missing from here. Whatever we've done with them, creating them, deleting them, we don't have the creation of these annotations here. Now we can't edit this really, which is good because it's history, but what we can do is we can create a workflow from this. If we click here, we have everything we've done. And we could, I think, select the steps that we actually want to use for their images. We want to create a workflow. For instance, if we have a project with a lot of similar images, we just do the analysis and the playing around with one of them, and then create a workflow that we can apply to the rest of them. So let's see. Set the image type, the stains. Why are these different? I guess I played around a little bit, so I'll take the latest one. We don't need this or this or this, but we did positive cell detection, the last one. And in here we can see the parameters that we used. So we have the image type, we set the convolution stains in the middle, we created manual annotations, we don't have that. Positive cell detection, and then object classifier, intensity classifications, hotspots, and annotations. So we've selected all the relevant steps that we would want to repeat in further images, and now we're going to create the script. Okay, with everything that we've done. Okay, my script editor probably has a larger font than yours, and that is because I set it like that. You can set it here. Set font size, I have it at 20. Do what you want to do with yours, but if you need to increase the size, that's how you do it. And then what commands do we have here? We can create new scripts or save this one. Normal, paste, copy, cut, things, view, set font size, language. I think the most common one is Ruby. Insert symbols, imports, classifiers. Oh, okay. So I think if we've created and saved classifiers, we can use this. Run, we can do normal run, which is for an image, or run for projects, which will be for all the images we have in a project. Oh. Okay, so it's quite readable, I think, even if it's not in language that I'm familiar with. So we set the image type, we set the color of the convolution stains, and so we have, what is this called? Name value pairs or something like that. We have the name, stain 1, value, stain 2, tab, value, and background. We have this, create annotation from pixel classifier. I don't think we're going to do this. Run plugin of positive cell detection. And then you have all the parameters that we used. Run object classifier, which is the one that we created and saved, so that now we have it here. We can use it again. Set cell intensity classifications. Find density maps. And create annotations from density map. Okay, so if we wanted to do the exact same thing that we did with the other one, we're still going to need some manual steps, which are those to do with annotations. So I'm going to create quickly here the annotations that we're going to need for this to work. I think what would happen if I say run and I haven't done the things that I need to do? it doesn't work. It's not giving me an error or anything, but it doesn't work. Right, let's create the regions that we need. Okay, let's say this is region. And then we also need annotations to train, I guess. So let's do I need this? No, because I've already trained a classifier, so I shouldn't need it. Okay, let's not do that. And let's try to run this again. Doesn't quite work. Why not? I'm gonna create a new one and just do. I'm not gonna do this. Let's try it like this. So it's true. Positive cell detection. You're not showing me anything. Why doesn't it work? Okay, what if I do a smaller annotation? Wait, is it... right. It's not going to work because it's not the same type of stain. The previous one was a nuclear stain, and this is a cytoplasmic stain, maybe? Well, the appearance is completely different, so that's why it's not working. Well, that sucks. Okay, so I guess that's why if you want to use scripts, I guess it's very, very important that obviously all your images have the same appearance, because otherwise it's not going to work. But at least we've learned how to see a workflow and convert it into a script, and possibly use it for other images, even though it doesn't work in this one. Anyway, I hope you liked it, I hope you learned something, and I hope to see you in the next video. Bye!